Welcome to the BetterHealthGuy podcast, where we take a deep dive into complex chronic conditions and explore ways to build resilience, improve vitality, and achieve better health. To stay updated on Scott's work, you can sign up for his newsletter in the show notes, where you'll also find ways to support the show and help make more episodes like this one possible. If you find the podcast valuable, please subscribe, rate, or leave a review, as it helps the show reach additional listeners exploring similar questions. The content of this show is for informational purposes only and is not intended to diagnose, treat, or cure any illness or medical condition. Nothing discussed on this podcast should be considered medical advice. As always, please discuss any health-related decisions with your own personal medical authority. And now, here's Scott, your Better Health Guy.
Welcome to episode 234 of the Better Health Guy podcast. If you are seeking new ways to create better health, I might just be your guy. Today, we continue part 2 of our discussion with Joshua Leisk on the Born-Free protocol. If you did not hear part 1 of our conversation in episode 233, I urge you to listen to that first, as it builds the foundation for our discussion today in part 2. We already introduced Joshua's bio in episode 233, so today we're going to jump right in and learn more about the Born-Free protocol and rethinking chronic illness through the lens of systems biology. And with that, here's part 2 of my interview with Joshua Leisk. We are back with Joshua Leisk, the creator of the Born-Free protocol. We had an incredible discussion in part 1 in episode 233. I'm looking forward to learning more from him today. Thanks so much for being here, Joshua.
Very welcome. Thanks for having me, Scott.
So we ended part 1 of our discussion starting to talk about lifestyle. We talked about diet. So let's continue by talking about the importance of the lymphatic system, which is part of detoxification and drainage, very high on my list. So how important are detoxification and drainage in recovering from these types of conditions? How much do you find the terrain matters? And then what are some of the tools that you're thinking about? Are you thinking about manual lymphatic drainage? Are you thinking about the Perrin technique? Are you thinking about vibrational trainers or maybe some homeopathic lymphatic drainage tools? What are you finding most beneficial for supporting the lymphatic system?
All of the above, and it's a tricky thing because different parts of the lymphatic system need slightly different methods to access them. So, for example, you can do all of the main stuff. I think there's also various programs like the Big Six, where you're sort of focusing on certain key areas. But there are also like lymphatic vessels in the back of the nasopharynx, which are extremely hard to access, for example. And the ones in the back of the nasopharynx, like underneath the ears, so the deep cervical lymph nodes and the occipital lymph nodes, are also responsible for the intracranial pressure. So they form a key part of recovery in the context of if you're doing anything to help the energy systems, which then help the immune system. The expectation is that you're then going to have debris from the battles which are ongoing because you've acquired a number of passengers while your immune system's been not so functional. And during that time, that could then cause lymphatic blockage, which then gives you compartmentalized metabolism alterations, pressure, hypoxia potentially, and a number of other things. So it's important to understand that the lymphatic system is not just a sewage system, it's also part of the fat delivery system from the diet, for example. So it does have multiple functions. And of course, it's involved in the ongoing immune response. So it's a critical piece. And the problem is that it's not something like the cardiovascular system where we have a pump. If I was to alter the design system around that, I would have, included a pump for the lymphatic systems as well. That's kind of a missing piece. So in that context, there's some manual therapy required to try to keep the lymph flowing to stop the buildup and, creating another bottleneck. So the immune system is going to calm down. In fact, there's a direct inhibition function when the lymphatic vessels are blocked. So that's something that is going to need to be addressed. So in the protocol, it's one of the things that actually is started before we've even started on repletion. So that way that the repletion, as it goes to, reestablish some of the energy metabolism, is not going to create a new bottleneck straight away. And the expectation is that the lymph nodes that are going to get blocked are going to be a clue as to where the localized infections actually are. They should be adjacent to wherever the tissues are that are infected. So nose throat infection is likely to have face and mostly neck lymphatic vessels that are getting blocked. Somebody that's got GI or gynae issues is likely to have blocks of lymph nodes around the groin. And any of the other ones sort of around the throat and the lungs and things like that are going to see blockages around the armpits and chest. So you'll basically come across these very regularly during the protocol.
Yeah, I think this is an area that there's definitely not enough focus and attention on. I'm very fortunate to have a great parent practitioner that I see about every 4 weeks, and that really helps tremendously. Let's talk a little bit about the stress component. We touched on some of this. So I think many people with these conditions are type A, perfectionist, overachievers, very bright people. You highlighted in our last discussion the key role of the sympathetic nervous system and sympathetic dominance and how that contributes. So how does cortisol enter that conversation? And do we become addicted to the stress in order to essentially mitigate the chronic inflammation? Does that cortisol become a crutch essentially? And then does that excess cortisol also potentially give the microbes more of an upper hand? And I'm going to keep going a little bit more, and then I'm just going to let you run with whatever comes to mind. But I want to talk a little bit about how much of the contributors to sympathetic dominance you think are more mental emotional versus more physiological, like we talked about before with things like sleep apnea, CCI, maybe some of those things. And then Dr. Neil Nathan has been my big mentor in the realm of limbic system retraining, vagal tonification, wondering how important those are to incorporate. And even though I don't see limbic system necessarily as mental emotional, it can be other factors like mold or chemicals or things of that nature. But how much do you find that trauma, adverse childhood experiences, and PTSD contribute to perpetuating the cycle of illness?
Very good questions. So look, I'll start off with the cortisol. So we have cortisol is kind of the slow, if you like, the slow increase towards the adrenergic signaling. It's not the big spike. You're going to see adrenaline and noradrenaline as part of a rapid response to some kind of transient event or some other catalyst event. Cortisol is going to rise and fall sort of slowly across the day in response to a number of different signals. Some of that's going to be just diurnal signaling as part of the normal daily cycle, but some of those are also as a direct response to metabolic problems. So in figure 4, I highlight how essentially some of the things which are detected by a branch that comes off the glycolysis pathway regulate a number of downstream pathways. And via that mechanism, essentially a sensor relay called phosphatidylserine, which then controls a lot of the corticotropin releasing hormone metabolism, which then kind of adjusts sort of a big shift between sort of anabolic and catabolic hormonal states. So in that context, it's detecting from the levels of glycogen, it's detecting the NAD redox, it's detecting P5P and the TCA cycle type status. So that's essentially coming from 3-phosphoglycerate. It goes through a dehydrogenase, that's the NAD redox. It goes through a transamination, that's the P5P and TCA cycle, and then ultimately ends up going towards either serine or phosphatidylserine. And then from there, it then regulates different pathways. So that's the sensor. As far as then the rest of the influences go, it's a really interesting topic. Anecdotally, one of the most common patterns that I have seen, in fact, it's almost pervasive throughout the entire spectrum of people that I've discussed this sort of topic with, but also helped along the way with patient advocacy and everything else that I've been doing. One of the big issues seems to be complex PTSD, childhood trauma is pervasive. It is one of the most common things that I've seen associated with this. If I was to speculate a mechanism around that, I would suggest that if the nervous system never learnt to regulate in childhood, and normally that's, co-regulation with your parents learning how to, sort of adapt to threats and ultimately that things are going to be okay. That's a hard lesson to not learn. If you never actually get the lesson that things will actually be all right, look, it'll get bad, it'll get better, life moves on. If that lesson hasn't really been installed in the nervous system, then as you're going into all sorts of really unpleasant, states of adversity and, metabolic dysfunction, the likelihood is that there is no kind of safety signal there to reach to. There's no light at the end of the tunnel. And so the focus then becomes on the current threat and the disease. Now, in this context, if somebody is neurodivergent and they happen to be able to be really good at holding on to, ideas and fixations and then going down rabbit holes for very, very long periods of time, far beyond, what the general population would be able to withstand. it's possible that that fixation then becomes part of the disease process. So essentially, the more you're fixated on the disease, the more you're focusing on that and not the outcomes. The good, the good things on the other side of the process that is going to be a little bit challenging to go through as you go through recovery. So facing all of the things that, are going to come up as you go through a process of restoring immune function and everything else. So in that context, if you look at a number of the figures, so figure 19, figure 18, figure 17 in my work really is describing part of the cascade as essentially chronic dysregulation of the nervous system, but complex PTSD is one of the key focuses in figure 17. But that talks about all of the things that go into that. So essentially the metabolic dysfunction, which is created by essentially the induced malnutrition, the heavy metals buildup, what happens with a number of the things with the sleep deprivation, which then triggers the loss of fear extinction during sleep. There's a whole range of different things that then focus on the opioid metabolism dysregulation, which is downstream of the microbiome, adaptation, I believe, to the sympathetic overdrive. And ultimately, the system itself is winding up and getting tighter and tighter and tighter and more rigid and pushing towards hyperarousal and hypervigilance as the cascade progresses. So ultimately, there is a huge input from the metabolism and essentially the progression of the mineral deficiencies and the heavy metal buildup, which is then going to lead to a number of interesting dysfunctions around the glutamate metabolism and the calcium channel metabolism. Substance P is involved in some of the calcium channel dysregulation or maladaptive response, and a lot of that's coming from the sympathetic overdrive. Now, if you cluster that in with the array of symptoms, which is going to include a lot of inflammation and pain, the nervous system, the autonomic nervous system, the amygdala is going to be seeing threats every day just by moving, breathing, eating, sleeping, all of these things. There is no safe place for it to actually retreat to. There is no place of safety. And in that place of lack of safety, you're going to be stuck progressively into a state of sympathetic dominance and overdrive, particularly if you've lost your glycogen metabolism and your parasympathetic signaling. So if you have nasal dysbiosis inflammation, if you're mouth breathing, if you've got problems with sleep, then the original parasympathetic signaling is not going to be there. And if the glycogen itself is poorly maintained, then there is no parasympathetic state to actually lean on. Everything is going to be progressively sympathetic. So if you want energy to get up and move around and things like that, that's going to be coming from an increased sympathetic signaling and then ultimately the systemic energy metabolism, so lipolysis, beta oxidation, that kind of thing. So there's the POTS and the orthostatic intolerance. If you need to activate your core muscles and balance to stay upright, then that's going to require energy. And if there's no localized energy storage, in other words, glycogen, then that's going to ramp up the sympathetic pathways and signaling. And there's the heart rate elevation as part of the escalation of that sympathetic tone. So it's just energy systems and ultimately where the substrates for the TCA cycle are going to come from. So moving on to some of the other influences. So vagal tone and managing that sort of input, absolutely helpful, really helpful, providing you then, of course, got the metabolism underneath it to fall back on. So if you're stuck in a progressively sympathetic bias and then you shift rapidly, say you do a stellate ganglion block or something even, if the metabolism's not there to support the glycogen homeostasis, then you essentially end up massively hypometabolic and you end up in the hole again. So you now crashed. So there would be a period there where you're trying to then eat and restore some of the nutrients, so not just the actual glycogen itself, but you've also then got all the cofactors that are required for that pathway to work. And it's not just like the magnesium and the phosphate for the top path of the glycolysis and glycogen synthesis pathway. It's also the minerals, so the chromium, the vanadium that's there for the glucose transporters and like insulin response. It's also the different things that are required to allow the oxidative pentose phosphate pathway to work. So that means the glutathione metabolism, which then needs the zinc and other things for the glycine and cysteine synthesis that comes out of the methylation and the transsulfuration pathways. And then obviously if the heavy metals have built up over time, that's going to be creating a problem there. And then, of course, you've got the thyroid signaling, which if that's a problem, then the hepatic gluconeogenesis is not going to be working particularly well. And so therefore, you're losing the glucose being sent by the liver from any and all substrates, which then are keeping the muscles and the brain fed and the glycogen stores fed. So that's kind of one of the key parts of all of this. If the liver can't keep filling in the gaps in blood glucose, then ultimately all of these hypoglycemia type episodes and especially around meal times and things like that, going to be a problem. And then progressively, of course, the brain and the muscle glycogen is harder and harder to maintain. So the alarm states are going to be progressively worse. And then the more the sympathetic overdrive progresses, the more you move into the inability to swallow, so the pharyngeal contraction and the GI motility shutdown. So the deeper into the sympathetic hole you get, the harder it is to even just, swallow and actually digest food. So it all sort of goes back to that mechanism. So the more that we can shift away from sympathetic bias and dominance into balanced parasympathetic to sympathetic state, that's ultimately the road to recovery.
And I would say that some of being able to do that and really being able to heal is letting go of our story, that it's really hard to heal when we're stuck in the story, in the trauma of illness, and that's driving a lot of the sympathetic dominance. In your disease model, you talk about blind spots in the immune system and the microorganisms that hide or shield themselves within biofilms in many different places in the body. So, why do we develop these biofilms? What is it that leads to a condition where the immune system has these blind spots? Is it that stealth infections like Borrelia are changing their outer surface proteins? Is it primarily the biofilms allowing the organisms to hide so that the immune system and even the things we're taking to eliminate them aren't reaching them? Is it the terrain? Is it the many insults over our lifetime that created a less capable and less discerning immune system? And then how does that tie into the way that you view autoimmune conditions when we're thinking about misguided or dysregulated immunity?
Also very good questions. Okay, well, starting with the biofilms. So the biofilms are created by the microorganisms. It's part of their normal life cycle. And they have a motile stage where they have like a flagella. They will be able to swim along and find a new surface. Once they find that surface, they then lose their little tail, their flagella, and they create a biofilm around them like a cocoon, which protects them from various insults. And at that point, they kind of go from being a mobile single-cell organism to essentially a factory. They're sitting there inside a protected cocoon, taking metabolites in and producing metabolites, some of those which may be toxic. And once they progress far enough inside of that life cycle, they will then proliferate, and then they will then come out of that biofilm and then find a new surface area to stick to, and then lose their flagella and go through that process over and over again. The immune system doesn't have a real good feel for what's inside the biofilm. It treats the biofilm as an inert substance, largely. It doesn't attack it, and it really has no idea what's going on. So you have these little factories that are progressing over a tissue, and that could be in the GI tract in a mucosal tissue. It can be in the cardiovascular system with atherosclerosis. So in that context, the immune system has no idea of what's in there, but whenever the microbes can come out of those biofilms, which is part of the life cycle, the immune system can arrest that as a checkpoint. So it can't do anything about the existing ones, but it can, prevent the slow progression of those biofilms up until the point that the immune system is distracted with other threats, and at which point it stops that checkpoint. So if the immune system's busy with influenza, COVID, something else, then ultimately the biofilms get an opportunity to expand their surface area. So that's kind of one of the tricky parts. The immune system is really, really good at dealing with single threats for the most part. In an acute situation, it does a pretty reasonable, pretty amazing job of dealing with co-infections, but ultimately it struggles. The innate immune response has certain things that it can do, and there is like a flip switch. There is like a logical gate via JAK-STAT as to how some of that operates. It's a more complicated topic that we can go into. And then the biofilm itself, that expansion over time, and that might be a long period of time, it might be a short period of time, depending on the state of the immune system and the host signaling, is able to then grow, which then means that the metabolites that are being produced by those microorganisms increases. Now, hypothetically, and this is entirely hypothetically, but based on a couple of interesting studies, there was a study in, I think it was mice and not rats, that they essentially had an input to the hypothalamus, and then the microbiome in the animal model retiled in the gut microbiome within hours of the shift in the nervous system. So that was without any food input whatsoever. So we know from that there is a signaling, and probably not very well understood signal, between the host and the microbiome, and then the microbiome essentially adapting to what ultimately started as electrical signals in the nervous system. So how that works, not really clear. And hypothetically, I would think that it's more than just the gut microbiome that responds in this way. So somehow this signaling works wherever those microbes happen to be, and they could be in the lungs, the scalp, the nasopharynx, they could be in the sex organs, they could be in any mucosal tissue, kidneys, other places. And then ultimately those microbes then get that signal and think they're doing something normal and helpful and proliferate. So in the context of sympathetic overdrive, the pathway essentially starts at the catecholamine. So we have like noradrenaline and adrenaline. Downstream of adrenaline then goes through a pathway called CAMP and PKA. So CAMP PKA then regulates a whole range of different metabolism, its energy systems, it's all sorts of different things. And interestingly enough, the body also is able to produce opioids, which then downregulate that CAMP pathway. So in that context, the way that that works is the microbiome, this is my belief, the microbiome creates this fermentation syndrome. The fermentation syndrome is essentially the alcohol to acetaldehyde. Largely, it's the acetaldehyde that ends up inside the system. And then the acetaldehyde alters the NAD redox in the brain, which then allows the dopamine and the dopal, or even just the dopamine and the acetaldehyde, if it's there, to react together to form salsolinol and a whole cascade of opioid alkaloids all the way through to morphine. So there is an endogenous pathway to morphine, there's codeine, there's everything else in that pathway. And so in that context, that then tries to balance out that elevated CMPKA. So if, for example, the sympathetic overdrive was coming from any and all sources, whether it's metabolic, whether it's, combination, and I think it's largely in most cases a good combination of metabolic dysfunction, and then ultimately the nervous system then adapting to that and then sort of progressively getting into a tighter and tighter sort of hypervigilant state, that sympathetic overdrive then needs to be balanced. The microbiome steps in, produces the acetaldehyde, the brain produces morphine, and then some kind of balance is created. However, unfortunately, that maladaptive response then also leads to the barrier dysfunction, the histamine dysregulation, part of the mast cell activation syndrome, along with the other mineral deficiencies and the other things, and also with the LPS getting through the barrier, which then leads to a lot of the other neuroimmune or neuroinflammation type problems.
And I'm going to take that, what you just said, and kind of bring it to our listeners here, a lot of whom are dealing with mold illness, and say that if the immune system is distracted with the external environment, that we then will have less microbial control, and that also then will result in the expansion of these biofilms.
It is, but there's also a big interplay between the latent lytic viruses too. So the mitochondrial dysfunction, which then leads to the lactic acid metabolism, so the lowered lactate threshold, that same signal, that same cascade. So when the fault sensors, the prolyl hydroxylases get inhibited, that allows hypoxia-inducible factors 1 alpha to stabilize. That is the thing that triggers the transcription factor alterations. So lactate dehydrogenase being promoted, pyruvate dehydrogenase kinase being promoted, essentially the glycolytic shift, but it also happens to be the trigger to trigger the lytic reactivation of various viruses. So in that state, you now have, this is when I was talking before about co-infections, you now have more threats. You now have this chronic reactivation of these herpes viruses, which are then creating a burden on the total system, but a distraction from the microbes. So your aspergillus, your candida, your various other things, and any range of any of these other microorganisms are not really getting suppressed because the immune system is burdened by a different class of pathogen.
So let's talk then more about hypoxia, since you just brought that up. So in my world, I kind of think of that tying into hypercoagulation, the accumulation of fibrin, which is a spectrum that then overlaps with the biofilm conversation as well. I think it's worse now in the world of spike proteins. So what is the role of hypoxia in complex chronic illness? What's driving it? Is it the infection? Is it the immune activation? How does succinate and hypoxia-inducible factor 1 alpha enter the discussion? And then how do we address the low oxygen state or hypoxia, but also being cautious about bringing oxygen into the gut microbiome, which generally is more optimal in a low oxygen environment?
Also good questions. Okay, so there are a number of things to unpack there. When we're looking at the oxygen transport, there are a range of different things that we need to look at. It's not just, say, like the fibrin amyloid type situation. And so, look, there are a range of different things. We've had problems with fibrin amyloid long before COVID, but it was a much smaller problem. You would see it typically in late stage diabetes and things like that, where we've got, an immunocompromised type of situation. What we've seen post COVID or ongoing COVID is massive increase in the fibrin amyloid issues being reported. And it's gone from micro issues to macro issues. There's been some quite amazing things being reported by embalmers and sort of other morticians and things. So it's been pretty interesting to see. In the context of the hypoxia, so it is one of the influences. We can have a range of other things which are creating problems with oxygen delivery and transport. So there can be, for example, the vascular dysfunction, and part of that is coming from nitric oxide synthase. So nitric oxide synthase is something that kind of sits in with the urea cycle. It's going to basically create nitric oxide, but it has a multi-purpose function. It's also, as far as I can see, part of the immune response. So in essence, it's one of the things that can generate superoxides in response to an upregulation of interferon signaling. So nitric oxide synthase and NADPH oxidase, they both appear to participate in the innate immune response. However, it does also have an element of dysregulation in the event that we have problems with BH4 synthesis. So BH4, it alters the metabolism of nitric oxide synthase, so what we call coupled NOS versus uncoupled NOS. So it's whether or not it also is creating ultimately the peroxynitrites as part of the metabolism or not. And then that leads to mitochondrial dysfunction and everything else as well. So it'll shut down complex 1, complex 3. We end up with additional inhibition. And of course, that mitochondrial dysfunction just kind of slows everything right down. Going back to the other influences. So we also have dysregulation of histamine and histidine. Histidine is required for the hemoglobin and ultimately the oxygen transport on the hemoglobin. So if we've got problems with some of the histamine metabolism, that's likely to have an impact on the oxygen transport there. Oxidative stress and rouleau, hypovolemia. We've got a whole range of other things that are going to be impacting that. And then, of course, if you've got circulating, parasites and bacteria and things, so Lyme and friends, Bartonella, Babesia, chronic immune activation, particularly with an insufficiency of the ability to process these reactive oxygen and nitrogen species. And that goes back to, again, the mineral deficiencies and heavy metal buildup. So that's like your Cu, Zn SOD, Mn SOD, catalase, and the big ones, of course, is glutathione peroxidase and glutathione reductase as the redox. So progressively, as all of these enzymes, these metalloenzymes are unable to perform their roles, then oxidative stress and nitrosative stress increases. So it's the metalloenzymes essentially being unable to manage and regulate the reactive oxygen species and reactive nitrogen species. So progressively, the outcome of that is, it's oxygen transport issues, cardiovascular issues. If the barrier dysfunction is progressing, then we might also have, additional problems with circulating biofilms, and there can be quite a range of species that we're seeing in the literature at the moment, P. gingivalis, strep and staph, and a number of things that are all creating biofilms inside the cardiovascular system. So, and then there's also the barrier for the blood-brain barrier and various other places which are going to be, acting to filter certain problems. But, if there's inflammation and things there, you've got another impact. And then, of course, structural issues. So if you've been in this mess for long enough and you have not just vascular, Ehlers-Danlos syndrome type metabolism, but also hypermobile Ehlers-Danlos syndrome metabolism, then you may also have chronic cranial instability. You might have impaired blood flow through to the brain. So the central nervous system gets a hypoxia alarm signal, which is a huge one from that particular input as well. I had somebody, really interesting guy, had upright Doppler versus supine. I think there was an 80% reduction in the blood flow when they're upright. And that was, coming from downstream of this metabolism too. So all of these things progressively create a tighter and tighter spiral into severe ME/CFS or long COVID or vax injury or whatever you want to label it as, whatever the catalyst is. It's a multi-system progressive failure, which then, can have some inputs to rapidly progress that at times.
Your comments are leading me beautifully into the next questions. And so you mentioned NOS. So I'm interested in your thoughts on where nitric oxide fits in for circulatory support. Is it less risky to support the nitrate to nitrite to nitric oxide pathway rather than the arginine citrulline pathway? We know arginine, for one, potentially is going to activate more of those herpetic viruses. So when does nitric oxide supplementation potentially move us in the right direction, maybe the endothelial NOS, versus the wrong direction by overstimulating iNOS? What do you see in the population you're working with?
Well, let's talk about the mechanisms a little bit there. So when we're talking about the viral reactivation, for example, so the risk, if you like, of using arginine or increasing the urea cycle flux is going to come from the anaplerosis to fumarate. So essentially, if the urea cycle spins up, one of the outputs from the urea cycle is at fumarate. So that's coming from citrulline through to ASA. And in that context, it ends up at fumarate. Now, in the context of hypoxia-inducible factors, which is the trigger for the viral reactivation, anything we do to increase the fumarate or succinate levels ultimately is the product for the prolyl hydroxylases. So if the alpha-ketoglutarate is lower than the succinate and the fumarate, then you now have a prolyl hydroxylase inhibition, which then leads to the HIF-1 alpha stabilization, which then leads to the viral reactivation. So in that context, yeah, it's one of the things that could be a factor to, incorporate. But then, by the same token, depending on the situation, if you are supporting the first half of the TCA cycle, it's quite possible that that's not actually going to be such a problem. So that's the magnesium, that's the iron status, the sulfur status, and of course the pathways that feed it, the substrate pathways. So fatty acid oxidation, transport, glycolysis, things like that. That said, if you fix a lot of these things, chances are you're also fixing the things that are correcting the nitric oxide synthase as well. So if we look at the context of nitric oxide synthase, it has quite a range of cofactors. It's a very interesting enzyme. So it's not just like the calcium channel metabolism, but it also needs like riboflavin in two forms. It has NADPH as one of the other cofactors, and essentially is upregulated as part of the overall innate immune response. So the things that I've been talking about with the NAD to NADPH regulation as part of the complex 1 inhibition, one of those factors, when there's interferon signaling in particular, but also extracellular ATP and other signals, is to upregulate and alter the nitric oxide synthase metabolism towards this shift. In the context of whether the dietary sources of sort of nitrates or beetroot and various other things that you might be looking at are safer, I mean, look, yes and no. It really depends. If the metabolism of nitric oxide synthase is still generating superoxide and peroxynitrites, that side of things is still going to be much the same. It's not necessarily going to be contributing to the fumarate increase as much, but do bear in mind that the other output from nitric oxide synthase ends up back in arginine to citrulline. So there is, ultimately you're still increasing the flux through the entire cycle.
In our last conversation, I think you gave people a lot of hope that are dealing with something like Ehlers-Danlos. So I'm interested in how often do you find that this population has structural issues or connective tissue issues, maybe thoracic outlet syndrome, maybe hypermobile Ehlers-Danlos syndrome, maybe the CCI type issues. How often do you see connective tissue disorders? Is it a large percentage of the population? And then do we need to combine both the aspects of the Born Free protocol and a practitioner that really knows how to work with the body's structure? So if we're thinking about things like biodynamic cranial osteopathy or visceral manipulation, what are some of those tools that you find helpful for addressing the structural contributors?
All right. Very good questions today, Scott. I'm actually really appreciating these. Okay, so the metabolism which is creating in the model, the connective tissue disorder is present. I see this across the board. It is pervasive, it is expected. So the model basically dictates that the connective tissue disorders will be seen at the same time as the metabolic dysfunction, which is creating the prolyl hydroxylase inhibition and a range of the other things which are involved in that. So the expectation is that the deeper in the hole you are with the mitochondrial metabolism, the deeper in the hole you are with the connective tissue as well. So ultimately, the reversal of one, if you're able to correct the mitochondrial dysfunction, will also lead to progressive, repair of the connective tissue, providing you then also couple that with stimulation. So much like going to the gym, the tissue itself needs to be provoked in a structured way to actually be rehabilitated. And so the thing is, if you try doing that while you have mitochondrial dysfunction, it can go backwards. It'll go, you'll end up with tears and things that won't be repairing properly. And so you can progress to a worse state. Once you've actually got working mitochondrial dysfunction, the model says that, yeah, ultimately you can go and treat the HEDS type connective tissue disorders. And that's standard rehab. That's essentially doing mobility work, tissue rehabilitation, and that's going to involve all the usual things to basically stimulate the muscles to adapt to, being able to support the skull or, various other tissues that are involved in that situation. So there was a posture course which I did back during COVID, which is linked in the protocol. That's free for people to use. There are a range of practitioners that will be able to help with essentially physiotherapy and structured physiotherapy around some of these things once the metabolism supports it. It's definitely not something that I would be pushing into, during the early stages.
And the only thing I would say there is make sure that that person works with conditions like EDS, because I've seen too many people that worked with people who worked with structural issues, but they didn't understand the complexities of EDS, and then they got even worse. I want to talk a little bit about oxidative stress. So what are the key contributors that drive oxidative stress in the body? Is it the chronic inflammation? Do we need to remove or mitigate or reduce that oxidative stress? Do the aldehydes themselves drive the oxidative burden? And then how much of the focus should be on removing those factors driving the oxidative burden as compared to the addition of exogenous antioxidants?
Well, it's a combination of all of these things. So, the generation of the reactive oxygen species is a normal part of metabolism. It's also part of the innate immune response. However, the body normally has metabolism to essentially not be susceptible to that state. So, normal mitochondrial metabolism will generate reactive oxygen species. And there's a diagram, actually, figure 14 describes this actually in quite some detail. So, there is a mechanism there which shows how the glutathione metabolism ramps up in response to oxidative stress and complex 1 inhibition, essentially acting as an automatic cooling system. So glutathione peroxidase activity ramps up and the glutathione reductase activity ramps up in response to progressive complex 1 inhibition. So during that shift towards induced malnutrition and heavy metal buildup, that particular intersection becomes progressively inhibited. So that means that normal mitochondrial metabolism is going to lead to oxidative stress. So oxidative stress in this context being an excess amount of reactive oxygen species beyond the capacity of the metabolism to cleanly react to and to metabolize. In that context, the more that we can do to reduce the heavy metal burden and restore the metalloproteome, the more capable the cells are in actually dealing with the tools that they're using to deal with problems, but also normal mitochondrial metabolism. So while the metabolism is stressed, while the ability to process these reactive oxygen species and nitrogen species is inhibited or impaired, then the more support that we can give from dietary sources of cannon fodder, so ascorbic acid and tocotrienols and tocopherols and various other compounds is going to be very helpful. It's basically just trying to restore that balance. And then ultimately, as we shift out of that really severe state, by restoring the metalloproteome and removing the heavy metals, then that resilience against normal metabolism plus innate immune response becomes progressively restored. It's something that we need to support initially, and then once the plane gets off the ground, then it can support itself. But in the early stages, it's just getting a leg up.
And just very briefly, do you find hydrogen, like hydrogen water, helpful in reducing some of that oxidative burden?
Generally, yes. I have seen some benefits. I wouldn't rate that as the most amazing thing ever, but yes. But also the acidity is the other aspect. pH is, potential of hydrogen. So it's again that regulation of how, the mitochondrial metabolism is also going to be working. There's a lot of complexity around that.
So let's talk a little bit about post-exertional malaise. What do we currently understand about what drives it? Is it the oxidative stress? Is it more complex than that? Is it the inflammatory cytokines, the interferon gamma, and how oxidative stress is impacting glycolysis and energy production? Maybe touch on what glycolysis is and what happens when it becomes impaired, how that contributes to fatigue, exercise intolerance, and post-exertional malaise. And then how might somebody know if they have impaired glycolysis or issues with glucose utilization? And then finally, how do glycolysis, glucose utilization, glycogen storage, mitochondrial function, and metabolic flexibility connect in the context of these complex chronic illnesses?
All right. So in the model, post-exertional malaise is a combination of glycogen insufficiency, which is then created in part, some of it's due to complexity around the diet, but the metabolism that regulates the glycogen synthesis actually comes from the glutathione metabolism. So the glutathione metabolism, as well as providing the cooling system for the mitochondria, so this is where the oxidative stress comes into it, it also happens to be the NADP redox. So essentially the oxidized glutathione, it is converted into reduced glutathione by glutathione reductase. That has NADPH as a cofactor, and it creates NADP as one of the products. There are a range of other enzymes, and particularly the ones in the oxidative pentose phosphate pathway, which go the other way. So G6PD, 6PGD, they take NADP and they make NADPH. And so if there is not a redox partner taking that NADPH and converting that back into NADP at a sufficient rate, then you bottleneck the flux through the oxidative pentose phosphate pathway. And why that's so critical is because that pathway is responsible for making PRPP and R1P, which are responsible for then making purines, pyrimidines, and NAD. So in that context, if we're unable to produce uridine triphosphate, So uridine triphosphate is used by an enzyme called UGPase in the glycogen synthesis pathway, but also for the glycocalyx assembly by making UDP glucose. Then essentially the cells aren't able to respond to any kind of serum glucose increase. So there is a dynamic regulation of the glucose uptake and conversion into glycogen and glycolysis, which is provided by the oxidative and the non-oxidative to some extent pentose phosphate pathway. So in the context of oxidative stress, if we've now reached a point where the glutathione metabolism is impaired because we have buildup of heavy metals, we have low zinc, we have impairments essentially to the methylation and the transsulfuration pathway, then we end up with the problems with the oxidative PPP pathway, which then means we have problems with the glycogen synthesis. Ultimately, this creates a cluster. It creates a spiral where we're unable to then produce enough glycogen to keep the liver happy, which is then meaning that we're suffering from the brain and muscle glycogen deficiency, and the oxidative stress which we're sitting in at this point in time is not really being helped by the sympathetic overdrive, which is now triggered as the lack of glycogen appears. So progressively, as the glycogen gets lower, the sympathetic tone increases. Now, hypothetically, that increase of sympathetic tone should actually increase the glycogen synthesis, providing there is an insulin pulse and downstream metabolism. But if the insulin sensitivity is now inhibited, because ultimately the oxidative pentose phosphate pathway is not responding to the glucose uptake, and then ultimately the signal, the pressure coming from glucose 6-phosphate and downstream, then you now have this really unpleasant situation where ultimately you can't get out of that hole very easily. You're now stuck in PEM for a period of time until you can calm the sympathetic signal down enough and get the glycogen stores up. But the challenge there is that because you essentially have sort of quite sharp insulin insensitivity during that time, a normal carbohydrate meal, let's say you're eating like 30 to 60 grams of net carbohydrates in a single meal, some of that's going to end up going in, and a lot of the others is going to end up as inflammation. So it's the same as somebody that basically has very poor glucose control. So lots of small meals, so like hourly 10 to 15 grams of net carbohydrates, like you had diabetes or metabolic syndrome, is quite helpful in that context to very slowly get the glycogen stores up and calm everything back down again. And obviously anything that we can do to help with the glutathione metabolism at that point and the oxidative stress is going to have a net benefit to the insulin sensitivity, which is then going to allow you to progressively get more and more of that carbohydrate to glucose spike actually converted to glycogen, which then ends up, into hopefully the TCA cycle, which is working at that point because you've also restored the glutathione metabolism and allowed the mitochondria to actually perform their normal roles. So it's a cluster. The axis that I refer to this as is methylation, glutathione, OXPPP. And essentially, the more that we can do to correct that axis, the less that we have to deal with PEM and POTS and everything else.
It is definitely a cluster, and maybe I'm thinking of that in a slightly different way than you intended it, but it is. You say that I anticipate there's a special place in hell reserved for clinicians who negligently misdiagnose ME/CFS patients with a purely psychological disease or anxiety, or force patients with measurable mitochondrial dysfunction from chronic infections, dysbiosis, and induced malnutrition to perform graded exercise. So what is the optimal approach to exercise in this community? Should we limit exercise to just below the level that leads to any negative response? And even with potential limitations, should we still try to at least be getting some movement? Do we get to the point that stagnation itself becomes another contributor to the problem?
Yeah, that's another good question. So yes, the short answer is that the body rewards us in some ways when appropriate. And this is the tricky part, is that, one person's level of appropriate is going to be very different to another person's level of appropriate. And it's really hard, for some people when you're getting signals, alert signals all over the place, danger signals, to actually ascertain what is appropriate and what is not appropriate. Until we get continuous lactate meters, which are, they've been on the cards for the good year or so, they keep being promised. It's kind of hard to measure that or to gauge that. But there is a way that you can progressively learn to interpret the signals. So the expectation is that the lactate increase is also going to connect with oxalate metabolism. So when you reach an inappropriate amount of exertion to the point that the cells are switching over to lactate metabolism, you may also notice the hyperoxaluria which occurs at the same time. You might feel the lactate in the muscle. You might feel the lactate in the brain. If the liver's not converting that back into glucose correctly, you might also feel, liver pain as well as part of that signal. So if you start looking for symptoms of what would have been overexertion, like getting a stitch back in the days if you're, athletic, these are kinds of things that you can use as signals to understand, okay, well, that was too much. So the goal is to allow your body to move. Yes, if you stagnate, if you don't move at all, then things are going to get progressively worse. You are going to deteriorate, in that context. But then, one person's appropriate level of exertion for the day might be flexing their toes and doing foot pumps and things like that, and some fist, sort of hand squeezes and things like that. That might be, enough to wipe them out for that day. Where somebody else can get up and go water the plants and go touch grass a little bit. It really depends on the context. But the goal is to not touch the glycogen reserves as much as you can. So that means, whatever the exertion is, trying to avoid glycogen. So that would be like low impact, steady state cardio. Walking when it's appropriate is great. Not doing high intensity workouts and things that actually dip into the glycogen reserves. So if you're going to go for a walk, don't go up hills and stairs and things like that are going to tax the glycogen reserves. Try and keep the energy usage to the fatty acid oxidation, so coming from lipolysis, as much as you can. Try and limit that to the ATP-PC pathway. So this is where creatine is so very, very helpful via the ATP-PC. The more that you can, keep the bursting energy to under sort of 8 to 10 seconds and allowing like a 30 seconds to a minute recovery of the ATP-PC stores, the more that you can avoid unduly using the glycogen storage. So little tricks like that while you're working on recovery is one of the things you can use to stack gains. But the goal is to ultimately stay out of a low glycogen state and stay out of an oxidative stress state for both of the same reasons. So knowing where your limits are, and during my own recovery, essentially what I did, and I failed it, a bunch of times in the beginning. That was just a learning process. Finding where my energy envelope was, using that, and then essentially just little bit by little bit, things would progress in the right direction. Trying to keep the nervous system calm, trying to keep the nutrition up. I did things, I think, incorrectly at that time during my recovery. I was only eating, probably because I only could at that point, once a day. I think that delayed a lot of my recovery process. Yeah, the end result was ultimately a very progressive recovery over 2 years roughly.
I think that walking is highly underrated. And I think that sometimes we think that it seems so simple that it's not really having significant benefits. But I feel like it's very beneficial within what we can do. Even that movement and getting the lymphatic system kind of moving, some fluid flows can be incredible. I try to walk about 4 miles a day. Now I realize if all we can do is walk to the mailbox, then we shouldn't go beyond the mailbox. But I think it's something that we don't put as much value on the potential of walking as maybe what we can get out of it. This next question is probably, maybe, we'll see, maybe the last really deep, complex kind of question. And then we'll get into some more questions and then kind of jump into how you approach the stages of your born-free model. But I want to talk first a little bit more about mitochondria, energy production, energy currency, ATP, NAD. So talk to us about the different types of NAD. So NAD plus, the oxidized form, NADH, NADPH. How are those impaired or dysregulated? And what is the pattern that you see in chronic illness? How much of the issue that we have with NAD dysregulation is driven by chronic inflammation? And then what can we do to support our mitochondria, energy production, so that every aspect of the body functions better? Does timing matter? Meaning if we're stuck in a cell danger response where that extracellular ATP is a danger signal and we aggressively start supporting the mitochondria, do we then have the potential for that to backfire? And even if it's not backfiring, can just improving mitochondrial function lead to either a Herxheimer reaction because the immune system now has more energy to respond, or a detox reaction because the body now is working through the backlog of things that have been unaddressed for years potentially?
Again, very good questions. I will start with the currencies and the redox. So in the context of all of these other currencies, ATP starts off as being the critical thing to allow the creation of each of these different cofactors. So if you look at the NAD synthesis pathway, it's heavily reliant on ATP. If you look at the FAD synthesis pathway, it's heavily reliant on ATP. There are relationships back and forth with all of this because essentially to create ATP, we also need NAD as well. So in the cytosol, but also then once we get to the mitochondrial metabolism, then there's NAD and FAD, and then of course there's also TPP. So all of these have a relationship. There is a diagram in the protocol which illustrates this. But then ultimately, so the elements, the magnesium, when we're thinking about ATP, it's not just the phosphate in the ATP, adenosine triphosphate. It's MG-ATP for the most part, and in some cases, it's also ZN-ATP or CO-ATP when we're looking at the riboflavin metabolism and the P5P metabolism, for example. So when we're looking at NAD, so NAD essentially exists in two states, and that's reduced and oxidized. The difference between the two is 2 electrons. That's the H. So in the context of the mitochondrial metabolism, the purpose of the TCA cycle, one of the purposes of the TCA cycle, it does many things, is to generate NADH and FADH2. The H ultimately is the electrons, which then gets fed via different enzymes into the electron transport chain, and then eventually to a pump called ATP synthase, which then generates large volumes of ATP efficiently. Outside of the mitochondria, the glycolysis pathway is the main ATP generation source. Although that's tricky because the first part of the glycolysis pathway happens to be an ATP consumer before the second half of the glycolysis pathway is an ATP generator. And that's critical because the zinc deficiency is one of the things that will actually inhibit the glycolysis pathway halfway along. So a zinc deficiency is required, fixing a zinc deficiency is required to fix a glycolytic ATP synthesis pathway and magnesium uptake, phosphate uptake, which then ultimately leads to the activation of all the other pathways to then generate NAD, NADP, everything else. Even the conversion of NAD into NADP is another ATP related reaction. So NAD kinase needs MG-ATP to convert NAD into NADP to add the other phosphate group. The big thing that converts then back and forth between some of these states is then the redox and the mitochondrial metabolism. So when we were looking at the complex 1 inhibition, so essentially the oxidative stress. Now, this is kind of where it goes back to reactive oxygen species having a normal function up until the point that they become inappropriate. So a certain level of reactive oxygen species generation and a certain level of complex 1 inhibition is required to create a little bit of NADH to then basically allow some of the NADPH to be generated. So this is the body rewards you for exertion. The body rewards you for generating a little bit of tiny amounts of oxidative stress to then allow you to create NADPH, which is then used for hormone synthesis. It's used for tissue synthesis. It's used for the methylation. It's used for a whole range of different things. But in this, the problem then is when it becomes inappropriate. So when essentially the NADH pool is elevated all the time, and you'll see pre-CFS, so basically someone which I would say is on the spectrum, where they've got elevated levels of hormones, for example, and like you'll see very high levels of testosterone or DHT or before we end up with the metabolic collapse. And, people will quite often think, oh, that's great. Look, I've got like a 30. I've got 30 for testosterone. And ultimately, that's one of the things that you'll see when there's the zinc deficiency and ultimately the mitochondrial dysfunction. So at that point, it looks good on paper if you're wanting to feel very masculine or something. But ultimately, you're already dysregulated and you're already in that state. So unfortunately, that's on the road. If you don't rein that back in, it's on the road to a range of different problems. So yeah, anyway, so the redox states, so they have different functions. So the NADPH you can think of as essentially a synthesis and immune related molecule. So it's involved in the NADPH oxidase activity. It's involved in the nitric oxide synthase activity. So that's part of the innate immune response. And obviously, as I was saying, the hormone synthesis and other pathways. So all of this is ultimately going back to the ATP generation first. So that comes first. This is why I think it's known as the currency. ATP is the currency of cellular metabolism. So it essentially is the activator of all these other synthesis pathways that generate all the cofactors, which then regulate all the other metabolism. So it is critical to get the ATP synthesis up to get everything else working. In the context of the detox and herxing and things like that, and the cell danger response, this is where it gets very interesting. So if we have dysregulated oxidative pentose phosphate pathway, which is that conversation before about the methylation, glutathione, OXPPP, one of the things that the model shows and the data shows when we're using the Theriome Aristotle testing is that the inosine levels end up low. Now, in the context of the extracellular purinergic signaling, ATP, when it's outside the cells and when it's triggered by various different signals, has the role of triggering the neighboring cells to go into an alarm state and potentially a relay where they tell all of their neighboring cells, hey, there's an alarm, there's a problem, there's a problem. So in the context of increasing the ATP availability inside the cell, potentially there is more of an availability to then trigger this extracellular purinergic signaling. So in the protocol, one of the things that has been added in the, fairly recent months, I think the beginning of the year, is actually a low dose of inosine. So it basically is there to help gate that extracellular signaling to stop a level 1, noise signal being turned into a level 10 threat, and then propagating more and more of the mast cell activation, immune response, dysregulation, all of those things. So what we might think of as a HERX, for example, could be simply dysregulated response to the purinergic signaling. And it's not that the cell danger response is a bad thing. It's a normal part of the body's response to tissue damage and all kinds of things. But like anything else, it can become dysregulated. And this methylation, glutathione, OXPPP axis essentially is one of the key things that will regulate or dysregulate that, along with the innate immune response. So essentially the NADPH generation, and then essentially the NOS and NOx overactivity. So the more that we can do to restore the methylation, glutathione, OXPPP axis, the more a lot of this then becomes appropriate. But in the early stages where we're just trying to get the head above water, supporting some of the calming aspects. So we want to cool down some of that innate immune response. We want to cool down some of that extracellular ATP signaling. And so that's what we're doing in the protocol. So inosine for the CDR, and we're using like very calming, like NOx inhibitors, which might be like low-dose spirulina, schizandra, low-dose curcumin. Funnily enough, there is cough syrup, which I don't use in the protocol, but is also another NOx inhibitor. So DXM, that also people will have seen is a help. They'll say, oh, well, that helps symptoms. Yes, it's going to also help inhibit some of the NOx activity and some of the oxidative stress generation. So all of this that is creating that spiral of oxidative stress and glycogen insufficiency is going to be helped if we can somewhere in that cycle break it by essentially calming down the oxidative stress generation.
I'm going to ask a few more, I think, shorter questions, and then I want to get deeper into the protocol and how you approach helping people recover. So if we think about chronic inflammation, cytokines, and interleukins that drive a lot of symptoms of chronic illness, like interferon gamma, TNF alpha, interleukin 1 beta, those types of things, are there some key drivers that come to the top of the list for you? And is it very similar to the discussion we had about oxidative stress, where we want to be both mitigating the drivers and simultaneously then potentially bringing in some anti-inflammatory materials to reduce the inflammation while we're working on mitigating those root causes?
Yeah, so there are a range of cytokines which are responsible for orchestrating changes in the mineral and the metal transport. Figure 12 on the diagrams page does a pretty good job of explaining that, I hope. TNF alpha, IL-6 is the big one, TNF alpha, IL-1 beta, 10 and 22, all responsible for altering the levels of a peptide hormone called hepcidin. And what hepcidin does is it inhibits divalent metal transporter 1 and ferroportin when it's elevated. There are a range of different things that will also influence the hepcidin expression and levels. The hormones are a big piece of that, a number of the minerals, vitamin D, blah, blah, blah. There are quite a number of different things that will help regulate all of that. And so in the context of vitamin D, for example, being anti-inflammatory or calming an immune response, part of that or inflammation, part of that is going to be coming from essentially allowing the metabolism to kind of normalize around the mineral transport. When we are looking at the upstream parts of it, so inflammation in itself, normal inflammation is good. It's a normal part of the tissue adaptation, response to exercise, immune response, all these different things. Where we have excessive amounts of inflammation and where that's coming from essentially malnutrition or induced malnutrition, and then essentially the metabolism being affected unduly, then it's unhelpful. It's inflammation for inflammation's sake, essentially. So the more that we can do to remove the unnecessary inflammation, the better. But that doesn't necessarily mean taking like a COX-1 or COX-2 inhibitor or targeting sort of galectin-based signaling. at the top, what we might want to do is say, okay, well, why is that inflammation there? What's creating that? Figure 12 does a reasonably good job, I hope, of indicating that the more that we can do to support the mitochondrial metabolism and prevent this excessive lactate shift, it's one of the big inputs towards the cytokine elevations that are then altering and creating that spiral around the mineral transporters. Sleep is another one. Someone reminded me on Twitter the other day. Sleep is going to affect the TNF alpha and IL-6, I think, or IL-1 beta, which is then going to have another big input into that. So that's another thing. The more that we can do to correct the metabolism and other influences on sleep, the overall benefit towards the positive trajectory is going to be realized. And then, of course, the other side of this is, again, the heavy metals, which are then affecting the glutathione and the TCA cycle and other parts. So it's more about the restoration of the repletion of minerals and the removal of the heavy metals that have built up. Figure 12 also does a reasonably good job, I hope. Particularly, I've done an update recently to really highlight that, how essentially the normal inflammatory process, so this pulse of hepcidin and the sequestration of the minerals and the metals into the brain, the liver, the kidneys, and the spleen, possibly other tissues, ultimately also includes the sequestration of these metals. And then if the glutathione metabolism is not there, allows them to accumulate in those tissues. So the more that we end up in this inflammatory state while the glutathione metabolism is impaired, the more we accumulate the heavy metals and the more that this spirals. So it's a focus on the minerals and the metals, I think, is the key to reducing the inflammation.
So you just mentioned the importance of sleep as well. You talk in the protocol about the importance of melatonin, that it can support the lymphatic system, the clearance of toxins from the brain. So are you using exogenous melatonin supplementation? And do you have any concerns with some of the higher dose melatonin protocols where people are taking 50, even 200 milligrams a day? Is there any downside to that?
There's no melatonin used in the protocol. It is something that could be used successfully. At this stage, I haven't actually included it. There have been times where I have thought about it. I think there was a period very briefly where it was even available. There are regulatory challenges in some countries even getting access to melatonin. In Australia, we have a very interesting regulatory process around, basic things. Everyone always says that Australia is a bit of a nanny state. This is one of those times we can't even get supplemental lithium, for example, as even at nutritional doses. It's just for whatever reason that just doesn't, pass the muster here. So in that context, look, melatonin, I think, can be helpful. There was a study recently suggesting that it was contributing in exogenous doses to potentially cardiovascular issues and some other things. I'm not sure that is correct, maybe in isolation, maybe in the same way that other influences will, allow certain processes to take place. I don't think there's anything inherently bad about melatonin. I think it's amazing, actually. It certainly regulates a lot of signaling for things like exosome export out of different cells during nightly cleanup processes. I think it's actually one of the key regulators for, cellular maintenance. So is it dangerous? Is it a bad thing? Well, I can't give a medical opinion, but the data certainly doesn't suggest that it is, anything that should be, evil or avoided any more than, say, vitamin C or other things might be. There are certain downsides to potentially using it, much like any other supplement or intervention. So in the context of chronic disease, I would say overall very helpful, but I wouldn't be using it in isolation as this is going to get you well.
It is my personal favorite drug of choice, melatonin.
Yeah.
So 2 more questions, and then we're going to talk protocol. So how often do you find that glutamate excess is a contributor? It seems like it drives productivity, but it's also bad for the brain. Do you find that you need to implement specific strategies for either reducing glutamate or for improving its clearance? How do you approach glutamate excitotoxicity and protecting the brain from its damaging effects over time?
Well, glutamate is a very interesting molecule. So outside the cells, it has the role of essentially stimulating activity. Inside the cells, it has the role of driving glutathione synthesis up. So in the context of when it becomes inappropriate, again, going back to this methylation, glutathione, oxidative PPP, and there's another input, which is on figure 18 with the sympathetic overdrive and some of the things downstream of that. What you'll notice is essentially that a dysregulation in the glutathione metabolism is likely to be one of the key contributors to eventually the extracellular glutamate levels being problematic or dysregulated, particularly in the context then of low magnesium and zinc, low P5P, low glutamate decarboxylase activity, so GAD, leading to an insufficiency of GABA in response to that elevated glutamate. So we see the glutamatergic dysregulation in a range of different things. It's not just ME, CFS, LC, PVS. It's also in ADHD, it's in autism, it's in PTSD. The glutamatergic dysregulation is a key part of all of these different things. Some would say that the overlap between all of these things are more than just sharing different things. I would say that there is intrinsic parts of all of these things which have a core or shared metabolic reason, and also a key shared nervous system dysregulation as part of this. The other one that's mentioned in figure 18 is the sympathetic overdrive cascade. So the dysregulation of CMPKA and what happens downstream of that, protein kinase A is one of the things that's going to lead to a shift in the glutamate signaling. So essentially, if you have this combination of sympathetic excess plus the glutathione dysregulation, the likelihood is that you're going to have an excess amount of glutamate. And particularly then if coupled with the malnutrition aspect, then yeah, you're going to have low GABA and elevated glutamate. So the outcomes of that are fairly predictable. Do we need to do better to support it? Well, yeah, fix this key axis, essentially. Get the glycogen working and get the glutathione metabolism working. And then, the expectation would be that this normalizes.
All right, my last question before we talk protocol. So how common is it to see mast cell activation syndrome and histamine issues in this population? How does that tie into the aldehyde conversation? And does clearing aldehydes improve histamine intolerance? Is the histamine being driven largely by the microbiome? Is it the mold exposure, the parasites, the EMFs, the Lyme co-infections? How does the Leisk lens view mast cell activation syndrome?
Well, histamine has multiple roles in the body, and it's expected to be triggered as part of, say there's barrier dysfunction and you might have foreign proteins slipping in. The mast cells are going to activate in response to that. It's also used as part of exercise adaptation. So it's used to regulate the glycogen distribution from the liver to the muscles post-exertion. And that's also using the immune system as part of that signaling cascade. So it's really important there. However, histamine also has the same sort of metabolism. So the same, like Mayo or Deo in this case, and then ALDH metabolism that the neurotransmitters also use in various other things. So we have histamine getting converted into an aldehyde type metabolite, and that's via like Deo typically, or it's essentially a monoamine or diamine oxidase, and then ultimately an aldehyde dehydrogenase reaction. So what can happen there is progressively as the oxidative stress, so if we've got problems with the mitochondrial complex 1 and the NAD redox, then we can have problems with the aldehyde dehydrogenase activity, which then leads to an elevation of the aldehyde metabolite downstream of the histamine being elevated. So if we have a combination of things where we have, because of the various mitochondrial dysfunction and the pathogens that are accumulating, barrier dysfunction then leading to foreign proteins getting through the barrier, we then have histamine release at the same time as problems with histamine degradation. So that leads us to mast cell activation, elevation, essentially sort of drowning in histamine, and then all of the the downstream effects that you would normally see with that. So in the context of how would you potentially solve it, and that's not the only other input, the cell danger response, so the mast cell activation or mast cell degranulation can actually be part of the extracellular ATP cascade. So it's very interesting in that context that you don't even need a foreign protein to trigger the mast cells to degranulate. You can simply have a nervous system signal for whatever reason, then triggering that histamine release. So that can be a pattern in the nervous system rather than any kind of foreign protein. There was also a really interesting study that was done where they put people in virtual reality. I think we were discussing this at one point, where essentially the nervous system and ultimately the immune system ramped up in the presence of a virtual pathogen. So in this context, a pattern in the nervous system or an understanding by the nervous system that there is a threat is enough to then be able to trigger via extracellular ATP in this context, the mast cells to degranulate. And then of course, if there is a problem with the histamine degradation pathway, that leads to an elevation of the histamine. And then depending on what's going on with the dopamine metabolism, so the cell context, this can then dysregulate the dopamine synthesis in different ways and push it up and push it down depending on the cell. And then that's going to have different effects inside of the brain. So histamine itself is a useful thing in the right context and is a very unpleasant thing when it is dysregulated. So the goal yet again is to restore the homeostasis, remove the external triggers and the foreign proteins, repair the degradation pathway, and then correct any of the nervous system influences that are going to be causing the histamine release.
I mean, it is amazing in your model. The one thing I didn't expect to come out in this conversation as much as it has is the role of sympathetic dominance and the nervous system. And when you suggest to people that they need to work on limbic, vagal, autonomic nervous system balance and regulation, it kind of triggers that it's all in your head type response, but you can really show the actual physical manifestations of a dysregulated nervous system. And we see people all the time that work on limbic system retraining, vagal tonification, and the nervous system, and that helps to stabilize the mast cells and reduce the histamine intolerance. So it is very clear, as much as it's offensive to many of us at the beginning when we hear these things, that bring us back to a lot of the gaslighting that happened over many years from the medical community. So as we get into talking now about your protocol, when you look deeply at all of the various pathways that are involved in the boron-free protocol, it is overwhelming for the vast majority of us. So do we have to assess and support every aspect of these pathway diagrams, or is it more about providing the right inputs, the minerals, for example, or removing those things that are contributing to chronic illness, like the metals and the infections and the biofilms? And then these pathways start to self-correct and find homeostasis, balance, function more optimally. How deeply do we have to, in terms of the interventions, dive to be successful with the protocols? Do we need to look at every tree in the forest, or does supporting the forest improve the health of the trees?
Well, this is a tricky one, because if you focus too much on the disease, you create the disease. So the more that you basically are caught up in the disease process and focusing on every little thing, the more that you're micromanaging and dysregulating the homeostasis. So you're essentially, stepping in to try to correct a problem, and in the process of doing that, essentially, contributing to it. So the idea is to restore the minerals, restore the resources that are there, pull the heavy metals out, and essentially get back to, as much as you can, progressively, a normal diet and normal lifestyle, and stay out of the way of the body actually recovering, which is so tricky to do when essentially you're being confronted with this disaster every day when you're awake. So it's a paradox, and it's a real, trying to essentially try to do the impossible when your brain is essentially fixated on the fact that you are sick. It's a tricky thing. No, look, you don't need to micromanage all of this. Essentially, it's restore give your body a kindness. Do your body a kindness by allowing the metabolism to be restored back to as close to homeostasis as it can be, and essentially allow the nervous system to reset and stop seeing threats. Because in the deepest, darkest, stages of the disease, essentially everything is just, horrifying. It's scary, it's threatening. The world is very small, and everything it looks like you do, nothing, there's no hope, there's no one's coming to help you. And ultimately every day just gets worse, and you're afraid of making the wrong decision, which is going to make things worse. And the baseline, get, lower and lower and lower. And unfortunately, one of the big challenges with the internet is that if you were to look at the online groups, that's all you're going to see. Doom and gloom, doom and gloom, doom and gloom. I can't do this, I can't do that. It's really, really tricky, because it doesn't do anything to help your mental state or shift the idea that you can actually recover, when what you're seeing online is everybody fixating on the idea that you can't. And look, as much as that's a challenge, the medical community has to actually take the brunt of that, because essentially they've allowed this state to propagate in the first place. If the medical community had better understood the disease and been able to help and treat people, then there wouldn't be this current state that we're in. People would have the right support that they need to actually get out of it. So that's where I'm doing my best to try to change things and change the way that the clinicians are able to help people.
So what I'm hearing there is that the body is innately intelligent and wise, and that when we attempt to control it, we're potentially then moving in the wrong direction. And that attempt to control it oftentimes is either driven by ego or by fear, but it's not trusting in our body's own innate design.
Succinctly put.
Okay, so now we're going to talk about the protocol and some of the supplement recommendations, a little more detail here. You have three main stages of the protocol. Stage one is remineralization, increasing collagen synthesis, performing a controlled initial die-off. Stage two is enhancing the gastrointestinal and mucosal interventions. And then stage three is stimulating and supporting a strong immune response. So talk to us first at a high level about each of those stages. Is it the same list of things for each person? Is it customized based on their OAT test or other testing, oligoscan, for example? How long is each stage? If someone maybe is a little more sensitive, can they stretch out a stage and introduce things more slowly so that they don't have maybe the potential for a Herxheimer or detox reaction? What's maybe the kind of minimum or maximum someone could be in any given stage? And how many different things might someone be taking or doing at any given time in those three stages?
So the beginning of the protocol is about restoring the balance and the mitochondrial metabolism. So that's the repletion. It's trying to put all the resources back into the cells and pull out some of the burdens. So getting the heavy metals, getting the mycotoxins out, restoring the glutathione metabolism, restoring the methylation, restoring glycogen, all of the things that are needed to get that cellular metabolism back to some kind of normal state. The process of doing that, though, is also going to then allow the immune cells to wake up and start doing what they've been wanting to do and go deal with a lot of the invaders that have accumulated during that time. So the expectation is that as soon as we start restoring the energy metabolism, the immune system is going to take priority and start dealing with some of the mess. Now, if we are not ready to deal with that, if we don't support that process, that can become a block, right? That can become a situation where you will suddenly end up with low glycogen. If the diet hasn't been correctly addressed, if the mitochondrial function hasn't been correctly addressed, then the immune system has the potential to create more of a burden than you're capable of sustaining. So in that context, we then need to be careful how we're proceeding and making sure that we're able to maintain glycogen and maintain the oxidative stress as we push through the initial immune response. So that's when the immune system is able to deal with the things that it can see. Later in the protocol, much later in the protocol, so stage three, after we've gone through a whole range of other things and already beaten down a lot of the burden, then we'll go chase the little reservoirs. That's stage three. So no one should be going near that in the eyes of the protocol until we've done all the basics and actually got to an almost normal life. Stage three is something to basically clear out the problems which have been left behind so that you don't have gut issues and, random infections in different tissues and all these sorts of things. You're essentially cleaning house to give you a fresh start. It's not, strictly speaking, required to break out of the initial hole that you're in. That's largely in stage one. Stage two has the targeted and also untargeted antimicrobial supports. So if you've gone through the extra effort of getting and it's really helpful, MicroGen DX and other data to understand what pathogens are there, you can then use different interventions to target some of these burdens. And it's not that they necessarily have a direct role in it's a cumulative role. It's not like any specific one infection creates the issue necessarily. But if you have an infection, for example, in the brainstem or other places, which is then impacting blood flow to the brain and ultimately creating an alarm state in the central nervous system, then anything that we do to remove that is going to be helpful in actually removing some of the alarm signaling. Stage two has a mix of, there's a product in there at the moment, which is very broad spectrum and hard to get at the moment, called GI Synergy. It's anti-parasitic, it's antimicrobial, so bacteria and various fungi and things. It's there as a broad catch-all. It has certain things in there that are not appropriate to use for long periods of time, berberine being one of those things. The reason the berberine is tricky is because in the context of mitochondrial metabolism, it's a complex 1 inhibitor, but it also is something that ramps up CD36, so the fatty acid transport, which if you haven't done it enough to correct the oxidative stress and other issues affecting carnitine synthesis, then you're going to end up with the fatty liver type metabolism because essentially the fatty acids are accumulating in the cytosol rather than being transported into the mitochondria and oxidized. So berberine is one of those things that you can have a love-hate relationship with, but for short periods of time, it can be very effective in dealing with certain problems. So again, what's appropriate? Now, if you have very good data and you have the usual overgrowth of a range of fermenting species, and that might be, again, the strep and staph and Klebsiella, E. coli, blah, 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 there are a range of different products that can be made available to deal with that. So traditional Western medicine has used antibiotics course, that is a little bit of a broad pen stroke for dealing with some of these things and can potentially take out a whole range of good species at the same time as dealing with some of the bad, quote unquote, species, the overgrowth. Coming from the eastern side of the world, well, at least the Soviet bloc and surrounding, there are bacteriophages. They are well advanced compared to the western side in dealing with very specific species. So over the counter in Russia and surrounding countries, so Belarus and Kazakhstan and other places, you can just go in and spend $10 or $20 and buy a range of different bacteriophage products without a prescription, take it, and if you don't have those pathogens, it's like consuming water. It does nothing to any of the other species, and it very selectively will target, infect, and take out like a particular strain of E. coli or whatever is actually susceptible to that bacteriophage. So the bacteriophage acts like a virus, goes in, infects, the particular species, replicates out to the neighboring species and goes through it like a chain reaction up until the point that they potentially do become resistant to that particular virus. So much like antibiotic resistance, there is potentially phage resistance too. So using these tools appropriately is very, very helpful. In the context, though, of why they're there in the first place, if we're going back to, again, the sympathetic overdrive being one of the potential major causes for the overgrowth of these fermenting species, it means that until you deal with that sympathetic overdrive, the chances are that you're going to continue to see this overgrowth of fermentation syndrome related species. Similarly, in that context, if you haven't dealt with the mucin and the butyrate issues, you're not going to be able to regrow the lactic acid and the bifidobacterium, so the lactobacillus and the bifidobacterium. And that's going to be one of the things. You could take probiotics to the cows come home. If the diet and the terrain doesn't support them, they're not going to colonize. So it's getting all of the host factors up before the microbiome is going to be able to adapt around that as well. So it's a combination. So we need to get the diet corrected. We need to clear out, some of the problems that have accumulated, and we need to reinstall the temple guards and janitors, which is the lactobacillus and the bifido. So that process is largely going to be started in stage 1 and progress into stage 2. Stage 2 has more of a focus on the removal of the bad things, but the expectation is by then that the sympathetic metabolism and signaling is going to be more balanced back to parasympathetic. So we're expecting that the removal of some of these fermenting species is going to be a lot easier. It's going to be working with the processes that we've already started. And then stage 3 is it's essentially the final step that we would use to clear out the reservoirs. So there's no point doing all of this if we're then going to leave behind infections in tissues and things. It's not contributing necessarily to the ME/CFS or long COVID or post-vaccine syndrome nervous system issues. Potentially it can be, depends on where the pathogens are. But by and large, it's one of those things that's going to be very helpful in allowing these little, if you like, sleeper cells, these pockets, these reservoirs of pathogens to come back and bite us later. One of the things that haunted me after my recovery, for example, was the GI issues that I had. And that was, I'd done pretty well in that for a while, but after a motorcycle accident and then another near-death experience and hospital antibiotics, I then ended up with gluten issues and things. And I didn't have any of the ME/CFS symptoms, but I couldn't eat gluten and I couldn't do a range of other things. I had GI sensitivities that were there. So it wasn't until dealing then with, certain problems that was able to be restored. Now I can eat gluten, I can do any of those things. I have no food sensitivities.
So what's the duration range of each stage? If I'm a more sensitive person, can I take more time in that stage? Do I still need to start everything on the first day for stage 1, stage 2, stage 3? How long are we talking about to get through the 3 stages?
It's a tolerance related progression. So someone that's really severe is going to need to take it gently. I mean, ultimately, what we're trying to do is show our body kindness and trying to get, the cellular metabolism working, the nervous system reset. We don't do that by banging on things with a hammer. We're not trying to just go in there and gung-ho, rip everything out and try and put everything in. That doesn't really work, and it's certainly not going to give the nervous system an easy time of it. So what we're trying to do is calm it all down, bring it all back to some kind of nice homeostasis. So if it takes a while to actually get the tolerance up for a number of things, then that's the time it's going to take. You can take your time getting things onboarded. Look, there are certain things that are going to be more problematic with some people than others. So the calcium channel dysregulation, for example, and the glutamate issues, you might find that somebody is going to be very sensitive to calcium. And in the protocol, you'll see that that's mentioned. Hey, this is something that you're going to need to titrate if you have this susceptibility. So the deeper into the sympathetic hole and the glutamate related issues, then the likelihood is that you're going to have to take the calcium slower. Looking at the autoimmunity type response. So the autoimmune regulation, and that's the way I'm going to frame that, of different pathways is something that we see. So you'll see, for example, autoimmune antibodies to like adrenergic receptors, to a range of different things. And what I've seen time and time again is that you could almost use them as a targeting assessment. So if you're seeing autoantibodies to thyroid tissue, for example, or to certain proteins in the thyroid tissue, so TPO and things like that, you can more or less say, hang on a minute, that pathway is dysregulated. The immune system stepping in to try to regulate that pathway because, it's really fallen off the rails here. And what you tend to see is that as you go through and start restoring the metabolism in that pathway and restoring the homeostasis, then those autoantibodies disappear. So the goal is to not necessarily directly target the autoantibodies, although some people would actually see a benefit from that if you've started correcting the underlying metabolism, because the autoantibodies essentially are a blunt tool in regulating those pathways. The IgG half-life is quite long. So you could start restoring the pathway, and then the immune system's adaptations to try to correct and balance things then become inappropriate. So the more gentle that we are in restoring these pathways, the less that the autoantibodies are going to then sort of push you in the opposite direction, because they're essentially, it's like being on a drug and the drug becoming inappropriate. It's the same concept.
And I would say what I see oftentimes, and this also comes from Dr. Neil Nathan's work, but in the more sensitive patient that isn't tolerating a lot of different supplements, it also comes back to the limbic, vagal, sympathetic dominance and nervous system, and putting that in place first, then they can better tolerate some of these other tools. I want to talk about just very specific questions about each of the stages, things that maybe stood out for me. So in stage 1, that remineralization piece, how often does that cause a die-off effect for people? Is it pretty much everyone? What minerals are you focusing on? And then is that customized based on, let's say, the results from their oligo scan, for example? Does the form of zinc matter? For copper, are you using a Cu1 copper or a cuprous nicotinic acid copper? And then what are the best ways when we think about magnesium in terms of forms? Do we need multiple ways of introducing it into the body? Maybe Epsom salt baths, for example. Talk to us about the key minerals that we're looking at in stage 1.
Well, the expectation of die-off and Herx is more to do with what passengers have accumulated while the immune system has been sluggish. So the expectation is that, look, at some point, you're going to reach a point where the energy metabolism and immune system is going to go pick fights with things. And that's expected. The context is there's going to be immune activity, you're going to feel sick. There's likely to be some Herx type reactions as well, depending on where the pathogens are, what they are, et cetera, et cetera. So it's expected. There's a diagram in the protocol which, sets the expectations around that, saying, as you start onboarding, you'll suddenly see the energy improve a little bit, and then suddenly there's a big immune response, GI distress, et cetera, et cetera. And then once you get over that hump, the baseline is increased, providing you get over that hump and you're doing things well. The different minerals. Okay, so this is where it gets interesting because the inflammatory cascade is essentially blocking the absorption. There are a range of different things that affect different minerals. We need to bypass temporarily, at least, or like the more we can do to get the inflammation down, the more the normal oral absorption is going to improve. So the tricky part is that cycle where essentially the inflammation's up because the minerals are already too low, or the heavy metals are too high, or the burden's already there. So it's then just trying to get some room to get these things to absorb. Now, since that's so tricky, one of the things we have done in the protocol is bypass the normal transporter route in the duodenum for a number of the minerals. So that would be, in the case of quite a range of things, sublingual or non-oral route. So we were using lozenges or troches that a pharmacy was making up. There's also all of the retail supplements which are listed, which are all non-oral route. Liposomal is another option that's going to work in many cases for many different things. And there is a DMSO-based route that's been highly effective, which we've been using for the last probably year or so. So that's been going very well. As far as the different forms, no, look, you don't necessarily need to use different forms of copper, for example. It is going to be something that you could get a benefit with if you can get, again, the non-oral route, make sure that it's being absorbed. DMSO, liposomal, things like that are going to be very, very helpful. Magnesium, you mentioned. Okay, so magnesium is interesting. The protocol did recently shift from different forms of magnesium. We were using magnesium aspartate, but look, really any of the other magnesium forms, which basically have like a compound or magnesium plus blah. And so in this case, it was aspartate. You could be using malate, citrate, various other things. There is a shift recently to using magnesium glycerophosphate. That's a little bit, hey, there we go. So that one's actually been a little bit exciting. The jury's out whether oral absorption works as well, but sublingual does, and it's actually interesting. Like it's warm in your mouth. If you open up the capsule, use the powder and put it in your mouth, you'll find it quite unusually warm. But ultimately, it's able to potentially drop into the glycolysis pathway after the main bottleneck. So after the phosphofructokinase, the PFK1 and 2, which is normally inhibited by low zinc, MGATP, elevated fatty acids in the cytosol, that kind of thing. So that is a little bit exciting. The studies on the glycerophosphate form were very interesting, but they were done in a pediatric situation where they were IV fed. So that was why the question around the gut GI absorption is still there. It needs to be properly studied, but it looks highly exciting. So it does appear to be the superior route to getting up the intracellular phosphate levels and providing the magnesium at the same time. Now, there are differences in magnesium uptake as well. So one of the dysregulated issues, and this kind of goes back to the earlier conversation about what you do with the nervous system and how this has an effect on different things. So the peripheral nervous system and the central nervous system, two sort of different sections of the same thing. The peripheral nervous system can react to all kinds of different things, pH changes. It can react to compounds in different plants and foods, and even just like fizzy water, for example, might be enough to trigger it, or vitamin C. And then that signal from the peripheral nervous system could be sending then an alarm to the central nervous system, which then sees that. And because everything has, central arousal of like the elevation of that signal, then turns into a systemic cascade and a whole body freak out, essentially. So trying to deal with that problem, like when you're going to react to things, might involve trying to calm the nervous system down first. So that's where like the inosine and some of the other things to help with the CDR and potentially some of the other aspects of getting the sympathetic signaling down are going to be very helpful, because there is sitting in the model, I mean, there's a diagram which I haven't put up there yet, but relates to figure 18. And basically what it's showing is that the calcium channel dysregulation is downstream of the sympathetic excess, which then involves substance P to then dysregulate TRPV1 and A1, and some of the others, which then basically create a lot of the reactivity to different substances and influences. So in that context, while we're trying to calm everything down, it's hard if you're reacting to things. If your nervous system treats a particular supplement or a signal as a threat, then it's going to be very hard to take it. So you might need to start off with essentially placebo doses, that kind of homeopathic type level of a particular compound or substance, to then allow the nervous system to treat it as a safe input. And so that's part of that exposure therapy, essentially, safe exposure therapy. Then back to the magnesium. So in the gut, some of the calcium channels are required for the magnesium uptake. I think it's TRPM7, for example. So with some of the calcium channel dysregulation, you might find that the GI absorption of magnesium is poor, whereas you might find that the transdermal route is going to be more successful. So that's the Epsom salt foot baths or whatever is going to be the case. Or in the case of the protocol, we have a magnesium spray or gel, which sometimes can be irritating, you can add water to, which is able to help at least get the magnesium into the system via a different route until things are settled down a bit. And then, everything becomes a little easier.
I think many people looking at the protocol would be surprised to see citric acid as one of the things that you're using therapeutically. I think many people, and I will say maybe with limbic system impairment particularly, are super concerned about anything with citric acid. I'm not saying some people don't react to it, but I think there's a big focus on not using things with citric acid. So are you using that more for the oxalates? Does it have an impact on biofilms? Do you have any concern that citric acid is often created by molds? Is that a valid concern? And do we need to think about the mast cell and histamine component when we're using something like citric acid that could potentially then liberate that?
Yeah, citric acid it's a tricky thing, but if you start off with tiny doses and again titrate, it's going to be less problematic and ultimately very helpful. The rationale for including it in the protocol is a number of things. One of those is the oxalate, so it helps dissolve oxalate and excrete it, which is in many people, when you're looking at the data, is a big problem. So the hypoxaluria we see progressively increasing with the lactic acid metabolism. So the deeper in the hole you are, the more problems with oxalate you're expected to have. That's certainly, the data that I've collected shows that in quite a significant way. Citric acid is also really useful for biofilm in the upper GI. So a lot of people will suffer from reflux and GERD. In part, that's from the zinc deficiency in the model, but also the biofilm, if it's in the upper GI has the ability to be producing gases, which then cause inflammation for the esophageal sphincter and the pyloric sphincter, which then is going to allow the reflux. Combination of all those things need to be dealt with, but the more that we can deal with biofilm in the upper GI, the less of these problems we're expected to see. But it also means that we'd be less reactive to simple sugars and things like that. So the dietary intake of simple sugars and fruit juice and drinks and things like that are ultimately going to feed microbes in the upper GI, whereas complex carbohydrates are not going to be digested and converted into glucose into much further down the GI tract. So what we're trying to do is remove the reactivity to different foods. So part of that is going to be by removing the biofilms that are containing these species in parts of the GI tract that is much less helpful. As far as then the histamine response, well, okay, citric acid does an amazing job of cleaning things, which is why it's in quite a number of household cleaners. It does a very good job of, well, progressively, I suppose, opening up resilience to things. So yes, it's likely to be a little bit of a histamine trigger, particularly if you're breaking biofilms, particularly if you're exposing immune surveillance to some of these things. But if you take things very slowly and carefully at your own pace, ultimately the goal is to allow your body to become resilient to all of these things. So avoidance is not the way to make progress. It's basically find a tolerable dose and move forward slowly.
In stage 1 and 2 and 3, there's a number of probiotics and things for supporting the microbiome that you're using. You talk about clean slate, reseeding and feeding, and then maintenance and monitoring. You mentioned in part 1 the metabolic daily product, which had the Clostridia butyric for the production of butyrate. That also has Akkermansia. What I've seen in some people that are chronically ill is they already have high levels of Akkermansia, and that can potentially then be detrimental to the mucin layer in the gut. So do you find that there's some people where we need to do some testing to see whether they need Akkermansia or not? Or is that something that you use with the vast majority of people?
Generally, it's used. Look, if the butyrate producing species was more readily available as a single probiotic species, and there is a European supplier that does actually do that, then yeah, you could potentially do that. But the Akkermansia elevation, more often I see in people where they've got a very narrow diet, very, very narrow processed food diet, and the microbiome seems to be trying to compensate. So the Akkermansia elevation appears to be trying to step in to essentially regulate something that's gone off the rails there. So look, I don't know. It's a tricky one. There is no perfect answer, but if you already have a lot of Akkermansia, you don't necessarily need to add more. That said, the amount of Akkermansia in that probiotic is only fairly small too. So it's not like it's a drop in the ocean if you've already got overgrowth. It's then more about what you're feeding and what the signals are.
Other aspects of your 3 stages are these do-it-yourself sippers and shakes and compounded nutrients. Are those the same for everyone? Or are they customized based on labs, and how readily available are particularly the compounded nutrients when we're thinking about people around the world?
The compounded nutrients are adjustable based on data. That said, the main things that I would mention would be the iron. So if somebody already has a TSAT of 40 or higher, then they're at the point where they're potentially accumulating iron. There's things going wrong with perhaps the cytochrome C, catalase activity, a few other things going on, possibly low cobalt. The last thing that we want to do at that point is add more iron burden to the system. So that would be one thing that would be inadvisable. So that's something that should be considered and tested. Generally speaking, the body does an amazing job of regulating the minerals. If there's excess, then the body does a really good job of getting rid of the excess. One of the things that I point to is the Jason Hommel protocol, the copper evolution, where he has people initially starting off with these tiny transdermal doses of copper and then upwards of 100 milligrams a day. We've had some of the copper evolution people coming through the group and essentially sharing their data, and you can see vast amounts of copper in their excretory data. So the body is essentially taking the excess and dumping it. It does a very good job of that. So in this context, I'm not too worried about nutritional doses of minerals creating a burden other than in far excess. So basically you have to step well out of a reasonable boundary and say, okay, we're actually reaching some sort of toxicity level. So you can, like in the same way that somebody would take a multivitamin, a multi-mineral, and not think twice about it, we're doing more or less the same thing with the compounded nutrients. That said, somebody can choose to be very specific in the nutrients that they're using. If the data only shows that they've got deficiencies, for example, in like zinc and copper and manganese and cobalt, then there's no point taking all of the other things that are looking okay. That said, if they're dealing with a chronic inflammatory cycle and if their diet's not, necessarily squeaky, then there might be a benefit in just allowing that level of support there. So you've got that peace of mind. But the goal is to stay out of toxicity, don't do anything too far out of boundary, and allow the system to reset. As far as the sipper and the shake and things, so the electrolyte intakes can be adjusted based on the dietary inputs. Like we're aiming for a total daily repletion target. In most cases, it's roughly around about daily values. So, for example, most people don't seem to realize that the potassium intake suggested by the regulatory bodies is actually around 5 grams a day elemental. And a lot of people are getting nowhere near that. And so they're quite surprised, particularly when you see things like potassium pills that are regulated at 99 milligrams. And that's largely because the pills are enteric coated and they end up in the wrong part of the GI tract and then potentially create inflammation and lesions for whatever reason. Whereas when they're consumed as a salt and they're in the foods, they're absorbed in a different part of the GI tract and present a less of an irritation or a problem. So how we go about that in the SIPR is you can adjust it. If you have an understanding that your general diet trend is going to include, let's say, 3 grams of potassium elemental a day, then you only need to really top that up a little bit with another 2 grams. So you can adjust your doses. There's actually an electrolyte calculator tool on the website that allows you to do that very easily. So that's essentially. So we're not aiming to. It's not a one size fits all as far as the recipe goes. It's adjusted to the total intakes across all sources.
I want to talk a little bit about the different forms of vitamins. So maybe let's focus on B1, 2, and 3. With B1, we hear a lot about benfotiamine. We hear about TTFD. You're using TPP or thiamine pyrophosphate, which is not a super common form of B1 as far as I know what's available here. I actually have some on the way from the UK from a resource that you shared. Do you prefer TPP over benfotiamine and TTFD? Is that the best form for binding aldehydes? And then let's talk about B2. So we usually think about riboflavin, but we also have R5P or riboflavin 5-phosphate, which is, I think, what you're using in the protocol. Is R5P enough? Should we also be using riboflavin? You talk about FAD or flavin adenine dinucleotide. I don't think we can get that supplementally. And then let's talk about B3. So we could be thinking about niacin or niacinamide, or even getting into NR, NMN, NAD. What are you finding most appropriate in that realm? And then, because we also touched on some of those that are phosphate, and we talked about the magnesium glycerophosphate as well, why is phosphate so important? And is there any potential of doing so many things that have phosphate that then we overshoot the mark and need to be cautious about that?
All right. So when we're thinking about these coenzymes, these B vitamins, they exist in multiple forms. So generally, the dietary intakes will be coming in the inactive forms. So you might have riboflavin. Riboflavin is then converted into riboflavin 5-phosphate or FMN, and then that's converted into FAD, which is kind of the active form, although FMN also has, some activity in certain pathways. So in this context, if we have perfectly working metabolism, if we have enzymatic reactions which are converting the inactive form into the active form and then performing redox and doing everything that is required, then there's not really much of a benefit in taking the active form. We can just get it through food and use the inactive form and allow the body to do it, its job. When we have mineral deficiencies that are affecting the metalloenzymes which are converting the inactive forms into the active forms, then we need to take a step further if we want to try to restore that metabolism faster. So in the context of riboflavin, we're using FMN or R5P, same thing, because we don't actually have access to FAD. If we did have FAD, I would be using FAD. In the context of B1, so there are a number of different challenges, actually. So we have thiamine itself. One of the big challenges I talk about is the aldehyde burden. So thiamine will act as an adduct for acetaldehyde and probably others, which means that the amount of the dietary thiamine that we're consuming is being lost as an adduct with the acetaldehyde and other things. So where benfo is particularly interesting is because it actually is fat soluble, doesn't necessarily bind to the acetaldehyde, and might have a better chance of actually getting converted via TPK1 into thiamine pyrophosphate. So the benfo might actually be a better source to get to TPP. However, we have access to TPP, so we can actually use co-carboxylase or thiamine pyrophosphate as a nutrient source and skip a lot of that as well. So that's one of the things that we're doing in the protocol and via the compounding pharmacy and other sources. The NAD, okay, there are many different forms of NAD precursors. So we've got niacin, and niacinamide is the other one. They're also known as nicotinamide. There's different names for these things. And then, of course, we've got the different versions of that. So we've got nicotinamide mononucleotide and riboside. Each of these have in their own right certain functions. So like if you were to take a big dose of niacin, you might see a niacin flush that you won't see if you came from a different source and you're using nicotinamide, for example, or nicotinamide mononucleotide or nicotinamide riboside. They all have slightly different pathways to get to NAD, although the normal dietary sources and the endogenous route via kynurenine all has a requirement of this oxidative PPP, so the pentose phosphate pathway and PRPP. So if we sidestep a number of the bottlenecks, we can use, for example, NMN or NR as a precursor towards NAD. But if we have problems with the fermentation syndrome, for example, if we have excessive CAMP-PKA, downregulation, or if we've got low zinc in some cases, it's going to be less efficient to convert the NMN and NMR into NAD. So for that reason, in the protocol, we now use NAD directly, sublingual route, bypass the gut and various other things, small but effective amounts, so around about, sort of 40, 50 milligrams a few times a day is appropriate. And then we then have to look at the redox. So there's some good examples. I put one on Twitter recently showing even if we're supplementing all of the NAD that we need, there was one example where the NAD, so again, the Therium Aristotle Plus, which gives us a direct analysis of this, we had one example where the NAD was 50% above normal and the NADH was 250% roughly above normal. So it was showing that the total NAD and NADH pool was more than sufficient, but ultimately the redox between the two states was a problem. So the NADH was elevated relative to NAD. And then because of other issues like MG-ATP insufficiency, the NADP and NADPH pool was actually very low, like negative roughly 500-600%. So in that context, the type of coenzyme that we use is important. So while the metabolism is struggling, using the active forms and non-oral routes is likely to yield a more efficient response to get the metabolism working again. And of course, as we start restoring the minerals and removing the heavy metals, then that becomes progressively less and less of a requirement. We can go back to just eating normal food. It's essentially getting around bottlenecks to affect a therapeutic response while the metabolism is impaired.
Any comment on the potential of using multiple things that are phosphate and whether that has any potential risk?
Acidity potentially is one thing, but really not much of an issue. I mean, we're talking about milligram doses of things versus gram level doses that we're actually trying to increase in the electrolyte intake. So you might be, for example, getting, between 300 and 600 milligrams of phosphor, which has a relationship then with phosphate, as part of the normal daily intake. So, 20 milligrams, let's say that we were getting TPP. If you were to have, let's say, about 50 grams of TPP, only ends up being a small fraction of that is actually the thiamine. So it's about, I think, a third of that is the thiamine, and the pyrophosphate makes up the other 2/3, for example. So it's, but in the grand scheme of things, unless you're doing something well outside of normal boundaries, there's not really a potential for upsetting, the balance.
Another interesting substance that's part of stage 1 is uridine, which I've explored a little bit over the years, but not in great detail. So are you bringing that in for cell membrane support, for lipid support, for nerve support? And then is there a reason that you prefer the uridine monophosphate over the triacetyluridine?
Well, uridine's a funny one. If you Google Mr. Happy Stack, it was something that I got famous for back in 2011, back when I was heavily invested in the nootropics research. It was just a thread on longevity that took off and still persists to this day. Lots of other companies making money selling a Mr. Happy product, which I, of course, get $0 for. But the uridine itself, look, it does multiple things. It's one of the things that can be very helpful for the phospholipids. It can be helpful for regulating dopamine metabolism. That was largely what the Mr. Happy Stack was known for. The primary reason I'm including it in the protocol at this point is more for the glycogen synthesis. So uridine monophosphate sidesteps the issue that we're talking about with the oxidative pentose phosphate pathway, and it's only 2 steps. So it's essentially uridine monophosphate to diphosphate to triphosphate to then essentially regulating the UGP as activity to allow glycogen synthesis. So in the context of the protocol, it's there to support the glycogen synthesis while the NAD redox essentially is inhibited, while the oxidative pentose phosphate pathway is inhibited.
So then we get into stage 2, which is more enhancing the gastrointestinal and mucosal interventions. One of the things that you introduced there is the good state ionic man minerals. Are you using that same product in women as well? Are they starting with one one drop and then slowly building up to that 4 to 5 milliliters that the company actually suggests. And eventually by stage 3, it looks like that goes even higher. So that is potentially something that someone could flare with if they increase too quickly, correct?
Very definitely. So look, it's the fulvic acid that's in that product is really useful for a range of different things: detoxification, biofilm breaking, and allowing minerals to transport even when there's an inflammatory process underway. It is something that, and again, it's the reason we start at one drop. It has the potential to dramatically shift the metabolism and create a strong immune response when you start using that. So it's one of those things, unless you're really ready to start transitioning to stage 3, it's something that you shouldn't really be touching in the context of the protocol. Some people will be okay, but the other people will react really badly. So it's something not to go near until you're actually, and look, until essentially you don't have the PEM issues. If you can get up and go walking around and kind of enjoying a fairly normal life at that point, by all means. But if you're still struggling to get out of bed, that's not an appropriate thing to look at.
And same product being used in women as well, correct?
Yeah. Look, the only very subtle differences in the mineral amounts, and look, other than marketing and product labeling, there's not a real fundamental difference. I think the emphasis around whether or not someone's got, for example, like 2 milligrams or 4 milligrams of manganese is kind of irrelevant. So,
the other thing in stage 2 that you're focused on is breaking down biofilms. You talk about biofilm phase 2 advanced, and you cycle that 4 days on, 3 days off. But then there's other things like NAC, glutathione, alpha lipoic acid, EDTA, other biofilm tools as well. You also start in stage 2 introducing some of the antifungal support with the undaselenic acid. So do antifungals themselves have the potential to increase aldehyde production temporarily? So when those organisms are dying off, is that kind of a defensive type response? And are you using other antifungals, other antimicrobials as well for viral, parasitic, Lyme, those types of things? I think you mentioned vanillin, allicin, berberine, and some medications potentially as well. So talk to us a little bit about the biofilm and microbial support.
well, there are a range of different things which go into that. And look, everyone's going to have slightly different species, and ultimately some of these things are going to be more relevant to some people than others. When the microorganisms pop, so when the cell wall is broken, a number of the toxic compounds that were inside the cell are released, and those can create a wave of toxins that need to be metabolized. And that can either happen potentially in the microbiome itself if things are going well, or alternatively, it gets circulated and the liver has to process it, and that's going to create a burden. And then you'll see, certain symptoms around that as well. There's also a potential symptomatically as you then work through this section. One of the things that we talked about was the opioid pathway. So when you go through and start clearing out the acetaldehyde production, there's a possibility that some of the symptoms that you're going to see are actually a net decrease in endogenous opioid synthesis. So essentially opioid tolerance / withdrawal symptoms. So that's mentioned in the protocol very, very specifically as one of the things to be looking out for. And ultimately, there are steps included to manage that process. So look, stage 2, there are things for candida support for different, common pathogens. The undeclinic acid is quite useful. There are a range of things that are generally helpful. And then, of course, there is, in the protocol, there is a table of different interventions based on different species. So if your data is good, if you've gone to the trouble of collecting good data, then you can focus on a specific intervention for a specific target. And so in the living without chronic dysbiosis section, there are quite a number of tables that talk about that. And there's also tables that talk about binders and things that it might be helpful in allowing you to do all of this with less impact on the host metabolism too. So it's really going to come down to, there is a generic approach, which is helpful broadly speaking, and then there is a specific approach, which is based on the quality of the data.
So stage 3 is stimulating and supporting a strong immune response while breaking the biofilms. You introduce mushrooms like reishi complex there. So what aspects of the immune system or microbial burden is the reishi supporting? Is it calming the inappropriate innate immune response? Is it supporting the lack of a proper adaptive immune response? Do people have flares with the introduction of mushrooms? And are you also using kind of isolated beta-glucan products as well?
Reishi is a really interesting tool, and it's a very complex topic. People will study just reishi for years and years and years. So depending on where it's grown, depending on the type, the part of the mushroom that you harvest, all these different things, whether it's the spore, the fruiting body, how it's extracted, whether it's a water extract or an alcohol extract. It has different compounds. There's different triterpenes, there are different beta glucans, polysaccharides, things like that. So the selection of the actual reishi product has been something that took many, many, many months and trips to the lab to understand what was in the different products and using the HPLC, blah, blah, blah. Very time consuming. So we're using the life extension reishi extract, and it's, yeah, look, at the time that was the superior choice by a long shot. There might be some other good products that could be also appropriate, but that particular one is very good. So what it does is it alters mitochondrial metabolism in a very specific way. It will favor the immune response and also unlock certain problems depending on the status of the the immune activity at that time. It's really helpful when used in a protocol in combination with beta glucans. So you have essentially a few things that are stimulating the NK cell proliferation, and then essentially you signal via the reishi to upregulate the immune response. Similarly, at that time in stage 3, there's also an increase of the inosine that we're taking in small doses for the CDR support in the early part of the protocol. That's now up to like much larger dose, like 250 milligrams to 500 milligrams in stage 3. So at that point, we're actually trying to really promote a robust immune response, because at that point, we should have an immune system and mitochondrial metabolism that's capable of actually dealing with these threats in a capable way. So, of course, if we start down that process before we've actually achieved functioning energy metabolism, it's likely to end up in a bad situation. So there is very, loud warning in stage 3, do not start this unless certain criteria are met. So, for example, if you're still seeing certain mineral deficiencies, if you still see like the low phosphate and sulfur in the oligoscan or the other data, essentially, if you still have PEM, all of these things are gates towards starting stage 3. Don't do it. The body's not ready, the energy metabolism is not ready to support that.
There are a number of binders that you talk about in your protocol, one of them being enteros gel, which I've used for many years, very interesting one. Do you worry about the heavy metals that might be in some of these binders, like zeolite, like bentonite, for example, like diosmectite? Does that concern you at all? Are any of these binders actually helping to remove the aldehydes from the system, or what are the primary things that you're attempting to remove with the binders?
Well, the binders are already binding the heavy metals. They're fairly inert in that context. And look, things like, for example, fluoride and aluminium, things like that, you'll actually get from drinking tea. The exposure to these things when they're in a free ion form versus already bound to the binder, it's a different proposition. It's a different, concern or risk. So no, I'm in the context of bentonite and diosmectite and things like that. No, I would not be concerned about absorbing the heavy metals that are already bound to the object that's not, or the compound that's not absorbing into the body. Different story with the nano type. There's like nano versions of some of these binders. I have concerns around nano minerals, nano metals, any of those. Like it's really not well understood and studied. It might be really good. However, it might also be really bad. And so for that reason, there's some context in the protocol that these are things that I would normally avoid. There are different things. Look, there's a table of targets and things, the affinity for these binders. So you might look at, say, like bentonite and charcoal, for example, very broad. They pick up like everything, good, bad. It just pulls it all out very efficiently. So that means that there is a limit to when they can be used if you're trying to also absorb nutrients and potentially medications and things like that as well. So whereas a narrower binder, so things like enteros gel, which might, for example, absorb acetaldehyde and some other things, but not necessarily broad spectrum pickup of different nutrients and drugs and things. So it's an interesting thing. So yeah, the enteros gel or silicol gel, very well tolerated normally, and it fairly narrow and helpful. It doesn't really get you into too much trouble. But the other ones, the bentonite and charcoal, great, really great. Just careful timing. It might be something that you would use at the beginning of the day or the end of the day to try to avoid pulling out the things that you're trying to absorb.
So who is this protocol intended for? Are people doing it on their own? Is it intended to be used under the supervision of a trained practitioner? Are there contraindications where certain people should not be using the protocol? How successful has the protocol been for people if they're able to continue with it? Does it get to a point where they're done, or is it kind of a lifelong maintenance type of protocol? And then building on that for practitioners, hopefully listening to this really incredible conversation. Your work is incredible. I'm really beyond impressed. How do they get trained to understand this enough, even if it's just starting to understand pieces of your model, to implement that in their clinical practice?
The thing about the protocol is it's available for everyone to read. As far as the implementation, and look, I think it's really important that the information is out there. So I've been criticized before. It's like, well, you've got dosing information and everything's there. It's like somebody could just go out and do it and try it. Well, look, in the context of all adults basically making decisions, having information basically gives you choice, and I think that's something that we're lacking when we're in this, disease state. Hopefully that choice includes having a competent medical practitioner to support and guide you on that journey. And this is why the protocol in multiple places will state, this should be done under the guidance of your, physician. The challenge has been that there have not been enough physicians that have been educated on this model to really go around. Like one of the things that I see is that people reaching out there are a number of clinicians which are trained or training on the model, but they're saturated now. So we're trying to continue expanding. And look, that's one of the things at the moment, the new institute that's being set up. I'm doing a lot of single and group training for different teams, different clinics. So that is progressing. Things are getting easier, but ultimately we need to scale up. And so the institute is going to hopefully fill that void and allow that scaling to take place. So there'll be a total ecosystem that's built up around the clinician education, accreditation, and the usual things like the continuing education points, et cetera, that are required to maintain your membership with your various boards or whatever. So the goal is to continue to expand the clinician education. That's where my focus is now. The tools that are on the Born Free website are also available with slightly different versions of that in the clinician toolkit, which is inside of the institute once you're a student or a member there, and ultimately the support and ongoing support which is available. So at the moment I do a lot of peer-to-peer consulting with clinicians when they're treating their complex disease patients, and just helping basically provide that educational gap, if you like, to understanding the model and essentially the disease processes, which I believe the model is describing very well. So the long-term goal is to scale up. I can't do everything. So it's institutionalizing the work and bringing it out to the masses. As for people that can and can't do it, I mean, look, I can't give medical advice as such, but the clinician supporting the patients would be better positioned to answer that. Hypothetically, look, if everything is done carefully and in an appropriate and tolerable way, hypothetically, no one should be in a position where they're avoiding nutrients. No one should be in a position where they're avoiding removing toxic metals and things like that, providing it's done in a way that doesn't upset the balance too rapidly. And that's kind of where it comes down to. It's like if you can't tolerate a slow titration of different minerals and coenzymes and things like that, there must be something that's actually blocking that. And is it the nervous system? Is it the metabolism downstream of that? Is it the immune system waiting to pick off a big fight with a group of pathogens that are there? And that every single time that you start to go through that repletion, you then end up with, say, intracranial pressure because you're not then maintaining the lymphatic system. So, or are there symptoms created by that immune response in the brain that are just intolerable? So it's dealing with all of these different things on a case-by-case basis, which is what the clinician needs to be empowered to do and what the patient needs to basically have some level of comfort around. And the challenge with that is that with all the different ideas out there, it's really difficult, for the patient to trust that they're getting the right advice, as far as how to approach it. So again, it just comes down to education and time. And I fully anticipate that in the fullness of time that we'll all have a much better understanding of how to go about this. But for now, it's basically putting the power into the hands of both the patients and the clinicians so that they can move forward with confidence and comfort, or at least tolerable discomfort when necessary.
So that institute is the Collaborative Sciences Institute. That's where you're doing training with practitioners. Do they have to be doctors? Can they be nutritionists? Can they be health coaches? Like, what's the scope of the practitioners that can learn more about your work through the institute?
All of those. I mean, look, there is a role, and I think, look, the clinical care model benefits when there is it's sort of similar to IT. So you have frontline support, the coaches, the mentors, the people that are doing the day-to-day support, the patient advocates. And then you have the different practitioners and specialists in the different areas. So you'll have somebody that's overseeing the whole process medically. They can then give direction to the carers and the day-to-day support people to then manage that process and then provide at a lower cost the day-to-day management. And so in that context, yeah, look, we're supporting everybody. So there's all of the functional medicine doctors, the GPs, the different specialists, neurologists, everybody else, naturopaths, and all sorts of other modalities as well. So also when you're looking at it from a psychological angle, when that support is needed, and if the nervous system work and coaching, it's all of that's there. And again, just to put that out there, it's not a psychological disease as such. But, trauma in particular has a biochemical, aspect of it. So if we're looking at, what happens with purely from that basis, you can see how the biochemistry is altered by trauma. There's many different, studies on it. You can look at the way that the immune system works post-traumatic. There was a post-traumatic event. There was looking at there was one of the bombings, I think, that they then went and studied the people a decade later, and their immune system was very different to the general population just from one event. So it's looking at all of this holistically and making sure that the level of care that the patient's receiving matches their needs. We talked about the complexity of the diagrams and trying to support every little thing. There are a couple of very simple diagrams in the introduction of the protocol, and it shows a spiral diagram of how, somebody might start off and then end up in severe ME/CFS or whatever named label we want to give it, and then ultimately the same process in a slightly different order to spiral back out of it. So it's more just looking at, how do you profile the patients to understand what are their key blocking issues that need to be focused on? It's like, is the nervous system the squeakiest wheel that needs the grease in the beginning? Do we need to focus on the tolerability of supplements in the peripheral nervous system? Which things actually need help first? But there is a suggested order, which I've included in that spiral diagram, where I believe basically each of these steps unlocks the next step. So doing things in a very specific and careful order.
I think with these conditions, one of the quotes that comes to mind again from Dr. Neil Nathan that fits really nicely is it's not psychological, it's neurological. Yeah. And my last question is the same for every guest, and that is, what are some of the key things that you do on a daily basis in support of your own health?
Sufficient exercise, sufficient self-care, go touch grass. Clean eating. So I like lots of, almost like a paleo type diet. So lots of raw, organic, unprocessed foods as much as possible. So eating like a rainbow of different organic foods. I find that important. Looking after your mental health, looking after essentially, the things that are going to traumatize you and create grief in your day-to-day life. These are all important things to look at. And then, yeah, it's look, I think it's one of those things. I think you're either in a growth state or a decline state. So it's focusing basically on growth rather than, the other transition.
This was such an incredible now 4+ hour conversation. I just want to really express my appreciation for all that you do to minimize the struggle, the suffering that so many people with these chronic complex conditions experience. I want to honor you for being a light in a world that needs more light. It was an incredible honor to interview you, to start learning about your work. I'm excited to learn more of it, but just so appreciate what you're doing and the difference that you're making in the world. So thank you so much, Joshua.
Thank you very much, Scott. Appreciate that.
Thank you for listening to today's episode of the BetterHealthGuy podcast. You can learn more about today's guest, including relevant links and resources, in the show notes. This podcast may provide community discounts and occasionally share links from affiliate partners. You can find this and other episodes on YouTube, Spotify, Apple Podcasts, Amazon Music, iHeart, and more. To learn more about Scott's personal journey to better health, visit BetterHealthGuy.com. Join us next time on the BetterHealthGuy podcast.